Good day, ladies and gentlemen. Welcome to Code Switching 2020. Today we continue with our physical sciences, grade 12, looking at electric circuit. This will be our question number 3. So as always, please pause the video, try the question, and then come back and look for the solution. So without any waste of time, let's get started. Today's question is as follows. In the circuit diagram, the amp of the battery is 25 volts and no internal resistance. The first question, they said calculate the total resistance of the circuit. The second question, determine the reading on ammeter 1 and 2. Third question, calculate the reading on the following voltmeters V1, V2, and V3. Let's look at our diagram. Our diagram, we are given the amp of 25 volts. Since there is no internal resistance, it's the same as the total voltage. So we have A1 and A2, which is our ammeter. Through A1, we have 30 ohm and V1, and also have 80 ohm resistor. We have V3, V2 on 55 ohm resistor, and last we have 70 ohm resistor. So 30 ohm and 80 ohms are connected in series, and 55 ohm and 70 ohm are connected in series. So let's look at the first question. They said calculate the total resistance of the circuit. As I've just mentioned, let's do solution for number 1. For us to get the total resistance, we see that we have two resistors that are in series first. Then we must calculate their total resistor. Therefore, let's say this is R series 1, which will be equal to 30 ohm plus 80 ohm. 30 ohm plus 30 ohm is 110 ohms. Again, we have 55 ohm and 70 ohm which are connected in series. Let's say this is R series 2, will be equal to 55 ohm plus 70 ohm, which is 125 ohm. So the two will be connected in parallel. I mean, you're going to have a circuit like this, where we have the sum of series 1, which is 110 ohm, and we also have the sum of series 2, which is 125 ohm. So now our resistors are connected in parallel, and this will give us our total resistance of the circuit. So we know that for us to calculate resistors in parallel, we say 1 over R parallel will be given by 1 over R1 plus 1 over R2 plus, depending on how many resistors you are given. Let's say R1 is 110. This will be 1 over 110 plus 1 over 125. When we punch on our calculator to get R parallel, you can just punch, open a bracket, 1 over 110 plus 1 over 125, close bracket, all to the exponent of -1. Then when you punch it on your calculator, you will get 58,51 ohm. Then our total resistor of the circuit will be equal to 58,51 ohm. Let's do a recap on the first question. They said calculate the total resistance of the circuit. When we look at our circuit, we have 4 resistors, 2 which are connected in series and the other 2 which are connected in series. So we add the total resistors in series, we got 110. We also calculated total resistors in series. We also get 125. So the sum of the two resistors, when we connect them together, they give us a parallel circuit of 110 and 125. Then our total resistance will be the same as the total resistors in parallel, which is 1 over Rp equals to 1 over R1 plus 1 over R2. We substituted 1 over 110 plus 1 over 125 all to the exponent of -1 to get the total resistor of 58,51. That's all for number 1. Let's look at the second question. Question B, they said determine the reading on ammeter 1 and 2. Okay, the ammeter reads the total current. Remember, when the total current flows in this wire, when it gets at this junction, it gets divided into I1 and I2, where ammeter 1 reads I1 current and ammeter 2 read I2 current. So meaning for us to be able to get the reading on current ammeter 1 and ammeter 2, we need to start by determining what is the total current of the circuit. To get the total current, you will say I total will be equals to V over R total. Our total voltage is 25 volts over total resistor, which we just calculated, which is 58,51. When we punch on our calculator, our total current is 0,43 amperes. So the total current will be going, the total current on A1 will be going through resistor 30 and 80. We're going to divide our total current into the ratio of, remember, on the first question, we draw something like this, where we call the total resistance of 110 and the total resistance on series on the second one to be 125. So this will be our current of A1 and A2, meaning our total current will be divided into the ratio of the resistors of 110 is to 125. Gonna divide our current into ratio by the total ratio of the resistors. It's 110 plus 125, which gives us 235 ohm. Let's check the current that goes on ammeter 1. It's gonna be I1 equals to the resistance of 110 over the sum, which is 235, multiplied by the total current, which is 0,43. Then the current that goes into ammeter 1 will be equal to 0,2 amperes. Then the current that will be going on ammeter 2 will be equal to 125 over the sum of the ratio, which is 235, multiplied by 0,43. Then the current that will be going on ammeter 2 will be 0,23 amperes. So when we add the two, you must get the total current of 0,43 amperes. That's how we get our reading of current on ammeter 1 and ammeter 2. We'll say the reading on current 1 is 0,2 amperes. On ammeter 2 is 0,23. Let's look at question C. Question C, they said calculate the reading on the following voltmeter V1, V2, and V3. When we look at V1, we need the voltmeter reading on resistor 30, where our current, which is in series, is the same as the one that was read on ammeter 1. The current is the same for resistors connected in series. So meaning V1 will be given by R, let's say I1 multiplied by R, which is our resistor 30 ohms. Our reading on ammeter 1 was 0,2 multiplied by 30. Then our voltmeter 1 will give us 3,6 volts. The reading on ammeter 2, the current is the same from ammeter 2 because of the two resistors are connected in series. V2 will be given by I from ammeter 2 multiplied by R. Our R, which is our 55 resistor. Then we got 0,23 multiplied by 55. This gives us 12,65 volts. Voltmeter 3 is the difference between voltmeter 2 and voltmeter 1. Voltmeter 3 will be the difference between the reading on voltmeter 2 minus the reading on voltmeter 1. The reading on voltmeter 2 was 12,65 minus the reading on voltmeter 1, which was 3,6. Then the reading on voltmeter 3 will be 9,05 volts. Let's do a recap on the last question. Calculate the reading on the following voltmeters V1, V2, and V3. As I've said that the current entering this point will be the same as the current through the two resistors, which is 30 and 80. So we have the current, which is from the ammeter reading 1 and the resistor. We substituted 0,2 multiplied by 30, we got 3,6 volt. Again, on the second one, V2, the current entering ammeter 2 is the same as the current flowing through 55 ohm and 70 ohm because of they are connected in series. So we have the current, we have the resistor, we substituted 0,23 multiplied by 55, we got 12,65 volt. Voltmeter 3 gives us the potential difference between V2 and V1. We substituted 12,65 minus 3,6. Then we got 9,05 volts. That will be all for today. Thank you for watching. For more videos, please go to Code Switching 2020.